Good afternoon, everyone. I hope you're all well today. For those of you that were expecting AGTC to present, and for those ocular groupies amongst you out there, I'm very sorry to disappoint. We were a late substitution, and so I was contacted late last week to ask if we would act as a pitch hitter. So let me introduce you a little bit to Antion Biosciences. So we are a very small startup based out of Geneva in Switzerland. And really our technology is focused on multiplex cell engineering. And what we're really aiming to do is take allogeneic cell therapy to the next level and really move beyond the amazing and incredible editing technology that we have at the moment and really push the boat out, making more efficient, more effective, safer, and cheaper cell therapies for patients to really change their lives. We're very fortunate in that even though we're still small, all of 17 people in the company, we have a great collaboration with Allogene Therapeutics, who all of you are very, very familiar with. And we're working very closely with Allogene to help them to develop their next generation allo platform. And so this is a really exciting time for us. So what I'm going to do today is just tell you a little bit about the technology, show you some very early data, and give you a teaser for what's going to be coming up in the coming months, because you're going to see a lot about Antion coming up. So all of you are familiar with allogeneic cell therapy. Everyone's developing CAR Ts. We've got a number of CAR Ts already on the market. All of them are autologous. And so the next logical step is moving into the allogeneic space. But we know from that perspective, in order to create cells that hang around, are persistent, that are efficacious, and that are safe, we need to modify those cells in a number of ways. It's not just a simple idea of taking out, silencing the TCR, and voila, there you have. So there are a number of different types of things that we really need to do. Obviously, the TCR from a T-cell perspective is incredibly important, but there are a variety of other surface receptors and internal receptors we may want to silence. And the current technologies that we have using gene editing, and this could be any type of editing, really creates significant complexity. These are multiple step operations. The cells are exhausted because they need to be activated, selected, and re-manipulated over and over again. And this results in a fairly high cost of goods, a huge loss of cells, and in some cases we're even seeing cells that are being put back into the patient that frankly are pretty exhausted and tired out. And so we really looked at this and thought, how can we improve this? How can we use our MyCAR platform technology to improve this? So we've really created a modular engineering platform that allows us to extend the way we engineer cells. And this starts right from the beginning using a bioinformatics approach. So using bioinformatics, and I'm not going to call it AI, I'm not going to call it big data, because my bioinformatician will slap me around the head. He's very, very traditional that way. But we have a really strong bioinformatics platform that we can take any target, and let's say it's PD-1 that we want to silence. We will do that all in silico. Not only will we create that target in silico, but we can test it against the entire genome in silico before we actually take it out and put it into an in vivo testing or an in vitro testing environment. Once we have it in vitro, we can select normally the top one or two constructs that we need, and then we can do additional validation and inspection on it. So what this does is this gives us modularity, but it also gives us an incredible speed at being able to adapt and change and design new constructs. So we can go from iteration of a construct to ordering it for the lab in a matter of 2 to 3 days, as compared to many other approaches. And so this translates to the MyCAR platform being very modular and very easy to replace different components. So what does it allow us to do? Well, in short, MyCAR is a platform that allows us to silence up to 6 different genes and add an additive component, be it a CAR or a TCR or a secretory molecule, all within a single construct in a single transduction step. So by doing that all in one go, we're able to then become much more efficient. Our manufacturing time comes down dramatically. The complexity of manufacturing also comes down substantially. This makes the regulatory folks and the quality folks very, very much happier, and the cost of goods obviously translate into this. So this gives us enormous flexibility in what we're able to do and create. Now, we're all familiar with the approaches of editing where we say, right, we need to edit out TCR and perhaps one or two other genes, and that's fantastic. But speaking to many clinicians out there, they are looking at the data that's coming out of checkpoint inhibitors and others and saying, well, hang on a moment, there are certain receptors we don't want to absolutely get rid of. We don't want this binary approach. We want to be able to tune the degree of expression. And this is really the benefit of the MyCAR platform. As we design our silencing constructs, we can design each construct specifically to the degree of silencing that we need. So we can take the first one can be complete silencing, the second one can be 50% silencing, et cetera, et cetera. So it gives us an incredible degree of flexibility. And so here you can see an example. Many of you are aware, obviously TCR from a T cell has to be essentially in excess of 99% absent. But what about HLA class 1? Many groups are taking HLA class 1 and they're editing that out. But in order to ensure that those cells, when they're put into the patient, aren't attacked by the NK cells, they're knocking in an HLA E or a G, so a minor HLA. But what if you could take that HLA class 1 and just detune it, and so decrease the expression of it, and you could turn it from a major HLA into a minor HLA, so you don't have to have those additional stresses on the cell. And here you can see in the data, what we've been able to show is we can go everywhere from 50% silencing, and then we can tune it 65, 85, 95, or 100% silencing for that specific target. So this gives us inordinate amount of flexibility in thinking about getting into a tumor microenvironment or other areas where you may have a variety of other signals affecting your effector cells. This gives that enormous amount of flexibility. So I went ahead to there. So silencing, as I've already talked about, offers some real advantages over the real gold standard that we have of editing now. And editing is absolutely incredible, and we wouldn't get to where we are right now without standing on the shoulders of the incredible editing folks. But this gives us some flexibility and ability to move on. So we've got that tunability that I've discussed. Our off-target effects, at the moment, we've looked for them very, very hard, both within our in silico testing, within RNA-seq, and in other mechanisms, and we've seen no off-target effects whatsoever. From a toxicity perspective, really important, because we're not creating double-stranded breaks, as you do with editing, we are not seeing any of that cell death or any of the toxicity related to any of those problems. Our delivery is very, very simple. It's a single transduction step using a lentivirus. So we can do this very, very simply, and we can use other delivery mechanisms. This doesn't really matter. It's very, very high efficiency. At the moment, we've been able to show TCR silencing in excess of 96% of the cells that are transduced, which is very much in and above the range that other groups are able to get. And our persistence is also incredibly strong. Most of you are familiar with messenger RNA, siRNA, shRNA, things like that don't last very long. Because the MyCAR platform integrates into the genome, we've got superb persistence, and that persistence really sticks around. And so we've been able to show in using this in other cell types, also not just T cells, but we've shown it in CD34 cells. We have data in Treg cells, gamma delta cells, NK cells, and we're in the process of developing this technology in macrophages also. So we've got an amazing persistence that you can continue to have this effect, so you have a very strong, lasting technology. Sorry, we've gone the wrong way. Right, so this allows us to really look at new technologies, new approaches in an incredibly exciting way. So you're sitting there and saying, meh. What's the data? What does it show? What have you actually been able to show out there? And so this is some data that we presented at ASGCT and ISCT earlier this year, where we created a construct that we transduced into T cells. And the first half is the silencing component, and you can see there we had 6 different targets, so 6 different genes were silenced, and you can read them all for yourself over there, and they're all pretty common targets that you might expect to be able to want to address. Not all of them are going to be in one construct, I grant you that, but this just shows off the capability. I think the important thing to realize is we made our lives a little bit more difficult in that we moved the CD3 zeta for the TCR silencing right to the end, to the place furthest away from the promoter and enhancer. So you would think as you go down the line, you might drop off in effect. And we did this specifically to be able to show that that's not the case, and we'll show that in a moment. And then on the other side, we had a CAR, and in this case, we used a CD19 CAR, the same as is used in Kymriah, so relatively standard, with a selection, a reporter gene, which allows us to positively or negatively select those cells as we put them in. So here you can see the data, and I don't expect everyone to be able to read all of this, but what's really important to see is that we're able to get very, very efficient silencing to what we were aiming for, whether it's a single construct or all 6 together. It doesn't matter. We can get the same kind of efficiency in silencing. And that continues on in vitro. We actually activated these cells over 29 days. And so they were really being pushed effectively, much more than you would have in a clinical situation. And that silencing remained consistent and effective and in place all at the same time. So we were able to show that this really was able to silence those targets we were after, and some of them we didn't look to silence completely, so we could show variations. But that's all well and good if your CAR doesn't work. And so obviously having a look at the CAR and the work around the CAR, we looked at the efficiency of the CAR. So you can see over here on the slides, the orange line is really an untransduced set of cells. So you'd expect at a 1-to-1 target effector ratio that you would have a little bit of killing because you've got to have something around. The light blue line is where we used a scrambled MyCAR sequence. So it's essentially the same as an autologous, just a CD19 CAR. And then the purple on the right-hand side was using silencing all 6 different receptors, all 6 different genes. And so what you could see on a 1-to-1 and a 1-to-3 target effector ratio, it was as good as the autologous approach. What was really interesting was at a higher target effector ratio, we actually saw better results. And so this was very, very interesting. Hand on heart, we weren't expecting it, but we were really pleasantly surprised, and that's something we'll be happy to report more data on as we look and investigate a little bit more into this. So with that, I'm going to end, and just a reminder, the MyCAR platform gives us incredible flexibility in silencing 6 targets simultaneously, allows us to do this in any cell type. It's all done in a single engineering step with a single construct and a single transduction step. We have the ability to tune that degree of silencing, which gives us enormous flexibility, and think about the options for CMC optimization. It really makes life for your CMC colleagues substantially easier. So that's it from us. I'd be happy to chat to anyone, give some more information. Look out for us at further meetings. We'll be showing some very, very cool in vivo data in the coming months. So thank you very much for the time.